Question 4. In the diagram below, the graph of f of x is equal to ax squared is drawn in the interval x less than or equal to 0. The graph of f inverse is also drawn, and points P and R are on the graphs. Let's begin with the first graph, f of x is equal to ax squared. And this is the graph, f of x. Now, f of x is equal to ax squared is a parabola. So why does our graph look like this? Because it's drawn in the interval x less than or equal to 0, and we're excluding x greater than 0. If we didn't have this restriction, then our graph would continue and we'd have a parabola that looks like this. But since we do have this restriction, we have this graph. We have f inverse, which is this graph over here. And f inverse is the inverse of the red graph. We've been given point P, and P lies on F. This is point P, and we've been given its coordinates. We have R on F inverse, and here's R, and we've not been given its coordinates. Now let's move on to the first question. Is F inverse a function? For f inverse to be a function, every x value must have one corresponding y value, and we can use the vertical line test to check this. We'll draw vertical lines through the graph like this. If any vertical line passes through the graph more than once, then the graph is not a function, because this means that for each x value, there's more than one y value. Now, since the vertical lines pass through this graph only once, f inverse is a function. If we look at each x value, we see that there's one corresponding y value. And here again, one y value, and the last line we've drawn, one y value over here. So let's write down our answer. Is f inverse a function? Yes. And we need to motivate our answer. So for every x value, there is only one corresponding y value. Moving on to 4.2. If R is the reflection of P in the line y equals x, write down the coordinates of R. So this is point R, and this is P. This is the line y equals x, and R is a reflection of P along this line. So the coordinates of R will be the coordinates of P swapped around. So here's P, and this is its x value. This is its y value. So let's write down R. The x value of R will be the y value of P, which is minus 12. And the y value of R will be the x value of P, which is minus 6. So the coordinates of r are minus 12 and minus 6. In part 4.3, we need to calculate the value of a. And here's a. F of x is equal to ax squared. So we have f of x is equal to ax squared. And f of x is the graph in red. So do we have a point on f that we can use to find a? Yes, we have point P here. So we can substitute point P into f of x. So we substitute minus 6 minus 12 into f of x. So x is minus 6, so f of minus 6 is equal to a. X is minus 6 squared, and f of minus 6 is the y value, which is minus 12. So minus 12 is equal to minus 6 squared is 36a. And to find a, we divide both sides by 36. That gives us a is equal to minus 1 over 3. So f of x will be equal to minus 1/3 x squared. And we can write our answer down here. A is equal to minus 1/3. In part 4.4, we need to write down the equation of f inverse in the form y is equal to f of x is equal to ax squared. And we know from part 4.3 that a is equal to minus 1/3. So f of x is equal to minus 1/3 x squared. And we'll write f as y equals minus 1/3 x squared. To find f inverse, we swap the x and y values around. So y will now become x is equal to minus 1/3, and x will be y. So we have y squared, and we want to make y the subject of the equation, so we multiply both sides by minus 3. So we have minus 3x is equal to y squared. So y will be equal to plus or minus the square root of minus 3x. And we're only interested in the minus value of y, so y is equal to minus the square root of minus 3x. And x is less than or equal to 0.